Welcome to another video from Lockdown Electronics with me, Bill, and this time we've got a multimeter review. But for those of you who get a bit irritated by them, if you can find an affiliate link to get hold of one of these meters, I'll be impressed, because the catalogue that I found this meter in is 49 years old, so it's a multimeter review with a bit of a difference, and I hope you'll enjoy it. I've been on eBay again, I'm afraid, and I'm very pleased with what I've got. Let's go and have a look on the bench. Well, here we've got the multimeter box then, and as you can see, in the last 50 years the box has had quite a hard life. Fortunately though, it's done its job and protected the contents. Now these meters were sold by Tandy, or Radio Shack as it was called in the States, and they had quite a lot of shops in the UK. One of the reasons I was interested in this is that Tandy headquarters in the UK was at a place called Wednesbury in the West Midlands, which is a bit of a obscure place in one sense, but that happens to be where I was born and grew up. So I was fortunate I was able to visit the Tandy store. It was just a bike ride from home, and used to enjoy looking at lots of things that I couldn't really afford. So when I spotted this on eBay and got it for just around £10, well, yeah, okay. And I think, as you'll see in a minute, it's in pretty good condition. So just a couple of comments about the actual meter. These I can't find a Tandy UK catalogue with a pricing. I can only find a 1976 USA catalogue with a pricing, and this particular part number was on sale for $29.95 US. Now if you do the historical exchange rate calculation and then you allow for UK inflation, that means that that's the equivalent price of nearly £350, incredibly. So this was an expensive purchase. Back in 50 odd years ago, it was a considerable outlay, and I'd have been extremely pleased to have one of these. Unfortunately, I didn't really have that much surplus income, so I had this thing. Actually, I had this in the late 70s, early 80s, which is a Maplin meter, nowhere near as well spec'd actually. I've just got the top of the box to cover up the meter, but let's just have a look at what we've got. And I think, as you can see here, it's in nice condition, very nice condition, very clean, and this is your classic analog multimeter. It requires 2 lots of batteries, and well, it's obviously got the analog display. And I think the first thing to point out is, if you're not familiar with them, we've got this arc-shaped mirror here, and that's to allow you to line up the meter needle with its reflection, to allow you to, if you like, allow for parallax when viewing the meter at the wrong angle. I have to say that I don't think the measurement accuracy is actually that good, but yeah, a lot of meters had that, as does this one. So that's the meter. It's in lovely condition, and this was actually a kit. Archer was a brand name used by Tandy, and Archerkit was the kit version. So this is a kit built instrument, and I was a little concerned initially, obviously, that the quality of the build might not be up to standard. I'm pleased to say actually it was perfectly alright. So if I just pop the back off, I've already removed the 2 screws to make life easier. So here is the view internally. Now I've put in a 9-volt battery and a 1.5 volt battery as required, but there is something else I want to show you that was in the box with it, and that's this, which is an ever-ready PP3. It's shows no voltage whatsoever. This is very old. I won't be chucking it out. This is such a powerful image from my childhood. Actually, these batteries were all that you could get for many years. Good old ever ready, and that's probably what would have been in it. I'm very pleased to say it wasn't left in it, because the connections for the batteries are in very good condition. So nice to have that. Very pleased it wasn't left in the meter. So yeah, you've got the two batteries, you've got the circuit board here with the various resistors, you've got this circuit board here, and you sort of build the kit, and down here there's a length of wire which is the current shunt for the 10 amp range, and the soldering isn't too bad at all actually. Could maybe done with cleaning the flux off a little bit better, but to be quite honest, you know, it's all right. So can't grumble there. Now what I have done is I've gone through some of these resistors, because all these resistors on here are 1% tolerance, and I've gone through them, measuring them with an LCR meter, and every one of them is still inside that 1% tolerance, which is very good. This potentiometer here is the 0 ohms range. We'll have a look how that works in a minute. And then there are 4 trimmer pots there that I've not touched. You're not supposed to touch them, they come preset with a little plastic sleeve over them. But that's the meter, that's its internals. I'm rather pleased with my purchase. So let's get set up and put it to the test. Okay, so I've currently got the meter here. I'm going to put it now into the 2.5 DC volts range, and I've got just the bench power supply, and I've got this digital meter here, and I've got as close as I can get to 0.5 volt. And we'll just point out that this meter is not calibrated, neither is the meter on my bench power supply, so you know, this is just a comparison. So I've got roughly 0.5 volt there. Now if I parallel these up, unfortunately the input resistance or impedance of this meter affects the reading on the digital meter, which is much higher, because it'll obviously have an FET front end. So I'm just going to have to swap the leads over. So if I do that, straight away the needle drifts up. Now we're in the 2.5 volt range, so if you're not familiar with how analog meters work, we need to use the range that says 250 on it and just divide by 10, so that, well, divide by 100 actually, so that's 2.5. So yeah, it's actually saying pretty much bang on 0.5 volt. Now if I wind up the power supply, and let's go up to what I think is about 2 volts there, just see it on the 200 or 2 volts if you like, and again the negative lead is very strong. Let's see what that makes of it. Yeah, it's within 10 millivolts, so on the 2.5 volt range that's doing pretty good. Let's go on to the 10 volt range and see what kind of results we get. Now I've managed to pull it's so strong that I've actually managed to pull the lead out, so I'm going to get another lead and then I'll come back when I've done that. Okay, here we are with a new set of leads magically appeared by the miracle of making videos. So I've got still got the same 2 volts, and now of course we're on the 10 volt range, so we need to use this scale that goes 0 to 10, and yeah, that's actually bang on at the 2 volts just there, so that's good. So I'm going to wind up now to about what I think is 9 volts, which is going to be just on that, just about there. I'm just trying to weigh up the parallax to do my very best to get it accurate. So I think that's about 9 volts. Let's see what the digital meter makes of that. Yeah, again it's within 100 millivolts, so yeah, you know, for an old machine it's not doing too bad. And finally I'll go into the 50 volt range. Now in the 50 volt range we're going to be using that second scale up there that finishes in 50. When you get used to that, it's actually pretty easy to use. So we're 1 bar below the 10 mark there, which does make sense. Yeah, that's 9 volts. Now my power supply only goes to well, that's about as high as I can get it, and I'm now going to try and adjust it so it's exactly on what I think is is 15 volts. Apologies if my header keeps appearing in the picture, probably doesn't, but trying not to. Right, I think that's about 15 volts. See what the digital makes of it. Yeah, 14.74, so that's a little bit lower. If I just increase that so it does read 15 volts, that's pretty close to 15 volts, 14.96. So let's pop that in and see what it makes of it. And actually, if I'm quite honest, if I allow for the parallax, that is maybe one needle thickness, which isn't very much, over 15 volts. So I think certainly the first 3 voltage ranges, you know, really can't complain about that. They're doing rather well. Right, I'm going to get set up, and we'll see what it makes of some current and some resistance. Resistance then is probably the most confusing if you've not used to an analog meter. So I've just got my decade box here again. These aren't calibrated resistances. I can't put a second meter in parallel because the input impedance affects the reading on the digital meter. But what you've essentially got for ohms is this top scale, and if you look as well, hopefully it makes some sense, it's not linear. So that's 0, that's 10, that's 100, that's 1k, so it's logarithmic really. And it works in an entirely different way. So I've got the decade box set to 0. I've just got a couple of leads on it. So if we put resistance onto R times 1k, the needle swings straight across and it's gone to the other end. So we use this adjuster here to 0 the meter at the far end. So we start at the right hand side. So that's the first bit you need to get used to. This was just how it did it 40 years ago. Just quite normal. So that's zeroed, and currently the box has got 0 ohms. So if I put 9 kilo ohms on, the meter has now moved. That's 8, that's 10. It's saying about 850 ohms, something like, sorry, yeah, 8.5k. I'm confusing myself here. Saying about 8.5k. And if I now come back to say 5k, yeah, it's just under 5k, about 4.8k, something like that. I don't know how well you can see that. If I do the parallax trick with the mirror, yeah, it's about 4.8k, something like that. So if I go on to the R times, well, I need to 0 this, otherwise yeah, the 0 doesn't apply to all ranges. If I go on to R times 100, again I need to 0 up the scale. I'm just using the parallax mirror to make sure I'm as close as I can get. So now it's multiplied by 100, so let's put on 900 ohms, and we're getting about 850, something like that, very similar to last time. If I put on 1k, yeah, we're up at about 950, so it does read slightly under there. We'll have a look what these numbers are on a digital meter in a moment, but you get the general idea anyway. And then finally, if I go to R times 1, I need to 0 that again. So this is the most sensitive range now. So if I put 5 ohms on, it is quite sensitive if I move about, but just out, yeah, that's saying about 5 ohms, something like that. And if I do 10 ohms on there, by the time it stopped wiggling, yeah, it's floating about, yeah, about 9.5 ohms, something like that. And finally, if I go to say 50 ohms, which is right across here, that's saying just over 40 ohms, something like that. Now, this level of accuracy would disappoint us today because we're used to looking at digital meters, but back in the day I'd have just believed it was 40 ohms and got on with it, because unless you're doing something that requires calibration, You know, you don't need you need to use a bridge to get really accurate measurements, but for the hobbyist this was perfectly good. And I do sometimes think that when you get a digital meter that gives you a number, you believe the number, and of course, you know, it isn't necessarily exactly right to the second decimal place. So yeah, that's the analog world, what it was like. So there you go. Okay, I'll just swap over and we'll have a look at the what the digital meter makes of those numbers. Switch the light out so it's a bit easier to see. That was 50 ohms. This is saying it's about 51 ohms, something like that. Just to emphasize again, this is not calibrated, so obviously, you know, you've got to make allowances for that. And if I go back to there, that's beeping away, it doesn't like that. Let's try 1K. Yeah, 992 ohms. And 9K is about 8.9, something like that. So you can see the decade box isn't too far off, and you know, if this meter's to be believed, then the resistance measuring on the Tandy meter isn't quite as accurate. But remember what I said back in the day, we'd have been quite happy with that. So there we go. Okay, final few comments then. When I got the meter, opened it up, and ohms times 1 was fine, but there was nothing on these ranges. So I opened it up, and obviously put batteries in, had a look, couldn't see anything obvious. So what I did was actually take out the circuit board that is immediately behind this switch, and of course there's a circuit board with the tracks on for the 3 meter contacts, and of the 3 meter contacts, one of the middle one was lower than the other two, so I very carefully rebent the spring so it was exactly the same height as the other two. And then I went over that did improve matters, by the way. Then I went over the circuit board with a glass fibre pen, gave it a spray of switch cleaner, and I have to say since then it's actually been working very nicely indeed. So there you go. That's a multimeter I would have been delighted to own 50 years ago. As I said, if you can get one online these days, well, you know, there you go. But why might I be so keen on an analog meter? Well, firstly, it's quite a nice thing, so I quite enjoy using it. And secondly, I've done an entire video on why would you use an analog meter. So if you look back through my previous videos, I'll put a link to it. You can see why sometimes having an analog meter is very good. And you may recall, just glancing back at the digital meter, many of them have a little bar graph, as there, because actually it's much easier to see the change in trend on a bar graph or a swinging needle than it is by trying to work out exactly what the numbers are doing. So there you go, nice bit of kit. Very pleased with my eBay purchase. Well, you might not be impressed, but I am. I'm rather pleased with that meter. In fact, I intend to use it on a few projects, so expect to see it again in future, appearing on the bench. I'm pleased with my purchase. It was a bit of a gamble as to how well it had been built and whether it was in good nick. Actually, with a little bit of cleaning up, for something which is potentially half a century old, it's working rather well. And it is a little bit surprising. I did double check my numbers that if I do the exchange rate in June 76 from the American dollars price across to UK pounds, and then work out what the increase would be for inflation, it comes to £349. You could get a very impressive meter these days for £349. So yeah, how the world has changed. I'd have been delighted with that 50 years ago. Would have been the best bit of kit I'd got. So yeah, things move on, and we need to be grateful for what technology brings us sometimes. Thanks very much for watching. Look forward to seeing you on the next video.